what we set out to do was we set out to make nanoparticles of magnetic nanoparticles and couple them together in a metal through metallic interactions. And what we found was a system that has very interesting electronic properties. In particular, it acts like a switch, where after a certain amount of time, the switch goes on or off. And what we found when we probed this was that at different temperatures, that switch goes on or off faster or slower. And what became clear fairly quickly is that food, in some sense, acts like this. And if you leave it out at warm temperature, it becomes bad faster. And our switch does that on pretty much the same time scales as food. So we're looking at it as a method for monitoring food, for example, milk, rather than have a date where it expires. You actually have a little electronic device on the milk that tells you when it expires. What we see as a benefit is that it will give the consumer more information, better information about how fresh their food is. We've had a series of excellent students. They do measurements, they do sample making, they do sample preparation, and we've had wonderful students. And a lot of our students go off and do PhDs at very good PhD institutions, and the process here is to prepare them for that. We've had excellent assistance from the Chancellor's Office through IUP, the Graduate School, Penn State Research Center, in developing the intellectual property, working on developing a patent, pushing the patent through. Potentially the device could have a lot of uses in the commercial market. You could use this device also to tell how much meat is aged. We're looking at pharmaceuticals. The Small Business Initiative at the IUP Business School is developing a business plan for this and looking at markets and looking to understand what the full impact on the markets are. So this could potentially extend out into the electronic realm and anywhere else where aging is a function of temperature, I think.